Right, we're going to complete the square expression. Now what we used to complete the square for was to solve an equation, to solve for x. Now there's another place where we can use it, and that is when we have an expression. Now where this is going to come in a lot is when we are going to work with the functions, with the graphs in the second term. So we can change the format of a quadratic trinomial to look different. Now you'll remember when we completed this square, we never changed the value of the equation. No? We just changed the format that it looked like. This is still the same here. But can you see we have a problem because we can't take something to the other side? Can you see that? Because there is no other side. Okay, so what we are going to do is the following. We're going to say x squared plus 8x, and then plus 10 is just there by itself. No? What's the perfect number I'm looking for? Plus 16, and then I'm minus 16 as well, otherwise I change it. Now the only difference, the only thing that we're going to do differently with an expression than with an equation, so we're still going to write this, square root it, that one sine, that one square root, close the bracket, square. And we are going to calculate that answer. It's going to be minus 6. And then we are done. Now why would we want to do that? When we're going to get to functions, to graphs, you remember in grade 10 when you did parabolas, your graph only moved up or down. And it was only positive or negative. But now in grade 11, come in, the graph can also move to the left and right. Now let me show you the problem with that. With these ones, your equation looked like this, x squared minus 4, for example, which means your graph was translated down 4 units. So you had that point there. It was your y-intercept, and it was also your turning point. It was negative 4. Then you factorized that thing, and you got 2 answers, minus 2 and 2, and you had 3 points, and it was easy for us to join. Do you agree? Okay. If we're going to look at this expression here, let's say that's a graph, then we can look at it, but we don't know that much. We know that this graph cuts the y-axis. You don't know this yet, but I'm telling you this. It cuts the y-axis at 10. Okay? And then we can factorize it, and we can get the 2 answers of the intercepts, the x-intercepts, which we did with that previous activity. Let me tell you what it was. Was it that one? No, it was a different one. Let's pretend it cuts at 2 and 6. Whatever, 2 and 8. Okay. So you've got a y-intercept and you've got 2 x-intercepts. Do you see the problem with drawing it now? In grade 10, it didn't move left or right. So your y-intercept was also your turning point. But can you see, we can't know if this graph goes down where exactly. It can turn there. I don't know. So can you see that the turning point is an important thing? And when we're going to change it to this format, that is going to be our turning point. That one and that one. Okay. So you don't have to be able to do it now. I'm just telling you why we want it in this format. Why are we doing this? Now the most important part about doing this is this minus 6, because it will be your turning point. The turning point's y value. Okay. And do you agree with me, when we have a happy graph, our graph reaches a minimum and then it goes back up. And when we have a sad graph, the graph reaches a maximum and then it goes down. Okay. So if I were to ask you if what this graph's minimum, or let me ask this first. Is it will it have a minimum or will it have a maximum? Because it's a positive graph, it's a happy one, it has a minimum. What is the minimum? -6. And that's what this format does for us. Does that make sense? Let me show you another one. Let's take all right. So the question might be, will this equation have a minimum or a maximum, and what is the minimum and the maximum? So the kids who don't know their work, they will say it will have a minimum because it's positive and the minimum will be 8. And they will be wrong. Okay? Because that one is not the minimum. It's once we've done complete the square, then that one will be the minimum or the maximum depending. Okay, so I'm going to complete the square here. X squared minus 6x, what's my magic number? Plus 9 plus 8 minus 9. The first 3, they're still my perfect square. And then plus 8 minus 9 will give me -1. So now we can answer this question. It's a positive graph, therefore it has a minimum. What is the minimum value? -1. So you see, if you think about this graph, it's going to turn at -1. It's going to cut the y-axis at 8. So it's not turning at 8. That one arm is going to go up. It's going to reach it there by the value of 8. Do you understand? Okay. So let's quickly look at these values, or these ones. Let me ask you. Let's see if you understand it. Okay. X squared plus 4. Remember, we can only complete the square when there was a middle term. If there wasn't a middle term, how did we get that third one? It was b divided by 2 squared. Now, if there's no middle term, it would be 0 divided by 2 squared, which is 0. So there's nothing that you need to add and subtract to that one. So like in this one, you see, there's not a middle term. All right. Tell me, will this one be a happy or a sad one? X squared plus 4. Happy or sad? Happy. So that means it has a minimum value. What is the minimum value? 4. Can you see that? Do you understand? Let's quickly think about this one. If a graph is positive and it has a minimum value of 4, that means it's not going lower than 4. If the x-axis is here, 4 will be there. It's not going lower than 4. Do you agree with me that thing won't be able to be factorized? Because we can't get x-intercepts. Because it doesn't cut the x-intercept. No? Okay. We must keep those things in mind when we're working with these. So we understand what we are working with. Right. The next one. Happy or sad graph? Sad. It's minus x squared plus 3. So it's sad graph. It will have a maximum. What is the maximum? 3. Okay, this one we can take out the negative, which means it's a, if I take out the negative in common, means it's a negative graph. It will have a maximum. The maximum is still -5. All right, so you get the idea. Let's look at this one. I don't want to look at the other two. Let's look at this one. X minus 1 squared. Positive or negative? Positive, so it's happy. It has a minimum. What's the minimum? 0. The one on the outside of the brackets. Those ones didn't have a bracket. Do you see? Okay. This one, now it has a bracket again. It's a -2. It's a sad graph. It has a maximum. What's the maximum value? 8. Okay, this one I need to take out the negative. So it's -5. Therefore, it's a sad graph. It has a maximum value. The maximum value is -2. Okay, because I only take the negative out of those two. Okay. All right. If we wanted to factorize and solve for x, we have two methods. We have the bracket, and then we have complete the square. Am I right? Okay. Now I'm going to teach you the third one. Right. What I'm going to do now, you don't have to be able to do, but you have to understand, because I need you to know where the formula comes from. Okay. So I'm going to take a standard form quadratic trinomial. In other words, ax squared plus bx plus c equal to 0. You all know what that is, ne? Okay. I am going to, and this is normally very difficult for learners, but I am going to complete the square. But I'm going to do it in terms of a, b, and c. So that just means when I have a b divided by a, I can't figure out that the answer is e. It's going to stay b over a. Do you all understand? So do you know that you have to focus now? Okay, let's look. If I want to complete the square, I first have to take out a out of the first two terms. Ne. So it's going to look like this. X squared plus b over a x. And then I close the bracket. And in this step, I'm just going to take the c to the other side, minus c. Are you happy? Didn't do something funny, I just took out the a in common. Now I'm going to complete this square. So the b value is b over a. So to get my magic number, I'm going to have to say b over a divided by 2 squared. Does that make sense? What is that thing going to look like? B over a divided by 2 squared. Where's the 2 going to be? It's going to look like this. B over 2a. Wait. Does someone have Tapex for me, please? I now already wrote the third term. Gooi. Are you going to catch? You first, Katlego. Okay. That is still the middle term, b over a. So the magic number is going to be b over 2a squared. And then I also have to subtract it. It's b squared over 4a squared. equal to negative c. I haven't done anything different. The secret to mathematics is that it all stays the same. Don't do funny things when there are funny things. Okay. So I just took the b over a, I divided it by 2, I squared it, and then I added it. And then I also subtracted it. Okay, so here I'm left with a bracket, this one square root, this one sine, this one square root, close the bracket, square. And on this side, I have minus c. Now quickly check what happens. This one needs to get out. It needs to get out of the bracket. How does it get out of the bracket? Multiplies with a. So can you see that a at the top is going to cancel out this square at the bottom. Then I'll be left with b squared over 4a minus, and it's going to that side, so it's going to be plus b squared over 4a. Do you all understand? So I added it, I subtracted it. I wanted to get out of the bracket, so I multiply with a. That a multiplied cancelled that square. So there's only one a left at the bottom. Then it was minus b squared over 4a. It's going to the other side, so it's going to subtract. Everyone with me? Okay. So next up, I just want to take a minute to rewrite it nicely. And then I am also going to somewhat divide with this a right here, right now. Okay. So I'm going to have x plus b over 2a, close the bracket, square. I'm dividing this one with a, I'm dividing this one with a, and I'm dividing this one with a again, so I have plus b squared over 4a squared. Now before I'm going to take the square root on both sides, I want to rewrite this side as one thing. So what will my common denominator be? It will be 4a squared. No. So this one has to multiply with 4a. Let me just show you. This at the bottom, I'm multiplying with 4a so that it becomes 4a squared. What I do at the bottom, I also need to do at the top. So it's minus 4ac plus b squared. Are you happy with that? And on this side, it's still x plus b over 2a. Square root. Square. Now I'm going to square root both sides. So on this side, I'm left with x plus b over 2a. And on this side, do you agree with me? I can't take that square root at the top because it's two terms. But I can take the bottom one. 4a squared can become 2a. So I'll be left with plus minus the square root of, and we're just going to swap those two terms around. We prefer to put the negative at the back. Okay, b squared minus 4a over 2a. Do you remember yesterday when we spoke about completing of the square, I told you your denominators will always be the same in the end. Do you remember that? Okay, see, even now, if I take this one over now to the other side, x is equal to this whole thing minus minus b over 2a. And do you see your denominators are exactly the same? So therefore I can write it as 1. X is equal to negative b plus minus the square root of b squared minus 4ac over 2a. I just swapped those two terms around. Is there anything else I can do? No. Is x alone? Yes. So what does this formula do? It does all the calculations you would have done when you complete the square. And it simplifies it to a single term. And therefore, if you want to complete the square, you can just substitute a, b, and c into these three variables, and you can solve for x. Your one sum, you'll put a plus between those two. Your second sum, you'll put a minus between those two. And then you've got the formula. Okay. And with this formula, you can factorize anything. Anything. Okay. Those ones that you were always struggling with the big coefficient in front of them, and even with the completing of the square, the coefficient made it difficult, ne? Now we don't have to do it because we've got the formula. But the formula we get from the completing of the square. Does that make sense to you? So this, you don't have to be able to do. But I want you to know where this comes from. It's when we complete the square in terms of variables. So let me do an example for you using the formula. So you're going to learn the formula and you're going to know it very well. And when they wake you up in the middle of the night and they ask you what's the formula, you're going to know the formula. And that formula is x equal to negative b plus minus the square root of b squared minus 4ac divided by 2a. Now often, learners get confused as to where the plus and the minus should be. Do you understand why the plus and the minus should be in front of the root? Because it was when we take the root over and we know we get a plus and a minus answer. Do you know why that b is negative right there? It was that last term that we took over, so it has to be negative. Alright, now we're going to use this formula and we are going to factorize and solve for x squared plus 9x equal to 36. You cannot use the formula if your trinomial is not in standard form, because then you won't be able to use the correct a, b, and c. So you're going to arrange it to be in the right order. And you don't have to do the following. I'm just doing it for the sake of the example. Can you tell me what is A? 1. What is B? What is C? Negative 36. Everyone happy with that? Okay. And now I am going to substitute into that formula. So remember, when we substitute, everything has to stay the same except the variable you replace with the answer given. So it's supposed to be minus b plus minus the square root of b squared minus 4 times a times c divided by 2 times a, and then I close the bracket. And now you take out your calculator, each and every one of you, because this is the hardest part of it all. When you type this, let me just ask, anyone who's unsure about the substitution? You all understand? Okay. When you do it on your calculator, use the fraction button. Okay? Then at the top, we say -9. And then I always start with plus. It doesn't matter if you start with minus. Plus the square root of. And you type it flippin' exactly as you see it there. Just as I saw it there. -9 plus the square root of 9 squared minus 4 times 1 times -36 divided by 2 times 1. And then you press equal to. And it gives you an answer of 3. And then you go back to your calculator and you don't go and type it in again. Just press that button to start at the beginning. And you delete the plus and you put in a minus. And you press equal to again, and then you get your other answer, x is equal to -12. And you can check it with the haki, because this we would have been able to do with haki, ne? Because they are nice whole numbers. Factors of 36, that will give me 9. Yes, 12 minus 3, that will give me 9. Our first step, get it into standard form. Let's make it fun. Let's take it to the left-hand side, so the coefficient, so a is still negative. Because I want to show you that now you can just leave it whatever you want it to be. So I'm going to make it -3x squared minus 7x plus 12 equal to 0. So if you want to, you can make it positive first. Divide with a negative everywhere. But I just want to show you with this example, it's no longer a problem. Just because of the example, can you tell me again what is A? What is B? What is C? Okay. So we start with minus B. So look at that, minus 7. Don't forget that double minus. Plus minus the square root of -7 squared minus 4 times -3 times 12 divided by 2 times -3. And then you take your calculator and you substitute exactly as you see it there. So it's minus bracket -7. And there's going to be one like this in every exam as well. Don't rush it. Rather take the time. You can even calculate it twice to make sure that you get it right. And you're going to know you're going to have to use it when they say round it off to 1 or 2 or 3 decimals. Because you cannot most factorize if you're just going to do bracket. What is that format called? simplest third form. Okay, if that asks you to leave it in simplest third form, you could have stopped there. If you want to give it as a decimal, you just press the convert button on your calculator, and this one's answer will be negative 3,48. And then the other one, I'm going to take out the plus, I put in a minus, and then my answer is x equal to 1,15, rounded off to 2 decimals. Do you all understand that? Is it difficult? No. Last example. I want to show you something funny. What's A? What's B? What's C? So it's minus B plus minus the square root of B squared minus 4 times A times C divided by 2 times A. Okay, you can calculate that quickly on your calculator. I'm going to calculate it here on the board. But you calculate on your calculator. Error? Yes. All of you? Yes. Quickly tell me, what is 1 squared? What's 4 times 2? Okay, what is 1 minus 8? Do you know why your calculator keeps giving an error? You cannot take the square root of a negative number. It's a non-real answer. What does that mean for your graph? It doesn't intercept the x-axis. This is a positive graph, and it's probably been translated upwards. Do you understand? Yes. So, now that you've seen that your calculator can throw out an error with these things, I hope you understand how important it is to be careful when you type. To be 100% correct when you put in your negatives and your calculations. And if you put the negative sign on your calculator where you wanted to put a minus, it will also throw out an error. And then you won't know, is it a real error, because it can be an error, or is it your error? Okay, so take your time to calculate it. Now I'm going to give you homework. It's exercise 6 on page 31. On page 31. I want you to do the whole of number 1 and number 2. So at number 1, they want you to use the formula as well, but they ask you to leave it in third form. And at number 2, they want you to leave it in decimal form, to 1 decimal. Just look here, like at number D and E and F, you first have to multiply and then simplify to get it to a quadratic trinomial standard form. Okay. Just one question that sometimes pops up in the exams. D. Can you all see D? 2x minus 1 and x plus 3 equal to 15. Listen to me. If that thing was equal to 0, that whole thing, but there is not a 15, it's a 0. Then you don't go and multiply it back in and then factorize again. You're going to end up with what you started with. But when it's equal to anything else than 0, you still have to multiply it in. Because when it's equal to 0, it means it has been factorized. And 0 is the only one that works. Because remember, 0 is the only number that you can multiply with anything and the answer is going to be 0. Not 15. You can't say 2x minus 1 can be 15 and x plus 3 can be 15 because anything times 15 is going to be 15. No. That only works for 0. But concentrate so you don't waste time in the exams and go and snarvel when it's already been factorized and it's equal to 0. Okay, we remember that. But these you have to. And this one is not fully factorized. Something has happened there. Let's see if you can figure it out. Okay, you can start now. I will tell you tomorrow. We'll know tomorrow if there were enough people to vote, so that you can know if you that I'm all said about it now, no? I did. Oh, boy, better you just went here. You must tell your parents to come and vote for the FGB, because if there are more than 140 parents, we can close the school at 12 on Friday. All right? And if we're going to close at 12, you guys don't have to come in for class. The beginning. So I don't have to save this class, no. I don't have to put it on YouTube, you're fine. Put it on. Okay, boy, then I'm just going to stop it quickly.